How are you, everyone? I'm doing fine, thank you. How was your exam? It was okay?
No more grade work, so I don't want to say it.
True. Every time I thought sometime the exam was good, my result was really bad. Anytime I thought the exam was bad, the result was remarkably good. So we cannot trust what we did in class.
I'll call you next week.
Okay. How about the questions? Like, are the questions similar to my review questions?
Very.
Very similar, right?
Your break is very helpful. I messed up a long crafting one. I just forgot, like I didn't practice it. It's like
Um,
other, I don't want to say other way. Think I did okay.
mm,
I understood, but then the graphic, I really didn't have to sit and think about anything. Like long episode things. I'm scared to say anything. Long episode new. The length of questions I was okay with, and I also like I was able to check my words. So like I even like showed like that I checked it on the side. So I think like I'm scared to like I think I really believe in anything. So I'm like
it's okay. We'll know next Monday. But I hope all of you did well in the exam. Your next exam is coming after 2 weeks or something, right? I already sent you the playlist. In that playlist, you'll see the third review video. Since our coordinator is the same coordinator, so usually we get the same, very similar exam every semester. Now, how about trigonometry? How do you feel about trigonometry? Do you like it? Do you dislike it? What do you think? Okay. Personally, so you already learned how to graph trig functions? Did you already learn that in class? No. Not yet?
no, like I learned it.
Hmm. So in trig functions, particle transformation is okay. Scaling is okay. The harder part is horizontal shifting. Horizontal shifting is red. Once you know it, probably I will talk about it in S class. Our next recitation, I think, has graphing question. But this recitation is easy. All we talk about is add function, even function, identity is the basic ones. So among the 6 trig functions we have, there are only 2 functions that are even. Do you know which 2 functions are even? No idea? Okay. We all know x squared is an even function, right? X squared, it's even because it's symmetry. So the left and right, they are the same thing. Now let me show you the graph of all the trig functions. Okay, my pencil. Observe the graphs. Sine function has this thing. It starts from 0, go up, go down on both direction. So one cycle is from here to here. This is one cycle. And we keep repeating this cycle again and again and again forever. Cosine starts from 1, it goes down, it comes back up again. This is one cycle. And we repeat this cycle over and over. And tangent is a cubic function, but we repeat cubic function again and again and again and again. So it has vertical asymptote at every pi over 2. we have another, and then we have another, same thing here, and then we have another portion. So the same cycle repeats over and over after every pi over 2 units. Now, observing these three, which one looks even? Sine, cosine, tangent. Which one looks even to you? In order to be even, the condition is that it doesn't matter which x you pick, the negative x or positive x, it doesn't matter. Your y is always same, regardless of which one you're picking. For example, if you pick x is -1, x is +1, they both have the same y value. If you pick x is -2 or +2, it doesn't matter. It has the same y value. So which one looks like even to you?
Sine.
Okay, let me pick a point. For example, I want to pick a point. I'm going to call it that. X is pi over 2. This is pi over 2. Okay. So this is pi over 2 with a negative sign. So for this pi over 2, this is our y value, right? Is it positive or negative? Positive. For this pi over 2, what is our y value? Positive or negative? So if it's an even function, even functions, it doesn't matter which x value we pick, positive or negative, you have the same y value. Do we have the same y value? So sine is not even. That means sine is odd function. Oh, sorry, my bad. I should write sine under odd. So sine is odd function. And since sine is odd, so its enemy, cosecant, is also odd. Go to cosine. Pick any x value. Anywhere, any interval. So any number from this interval to that interval.
0.
0 doesn't have any negative 0. Pick anything that is a positive and negative. For example, this one here, this one is pi over 2. This point is 3 pi over 2. This one is 2 pi. Okay? So pick anything besides 0. 2 pi. Okay. So for 2 pi here, our y value is here, right? Positive. So we have another 2 pi here, but this time it's negative because it's on the left side. What is the y value we have? Same or different? Same y value. Right? Now let's say pi over 2. Pi over 2 is here. So negative pi over 2 is here. For pi over 2 or negative pi over 2, what is the y value? Same 0, right? So you have same y value. It doesn't matter which x you pick, from positive x or from negative x. As long as you have the same x, they have the same y value. So what is cosine? Odd or even? Even. So cosine graph is an even graph. Cosine function is an even function. And since cosine is an even function, what else is even? Secant. So they are like enemies, okay? But they're so good enemies that whatever happens to one of them, same thing happens to the other one. If cosine is even, that means secant has to be even. They are reciprocal of one another. Since sine is odd, cosecant has to be odd. They are reciprocal of one another. Now, observing tangent, what do you think? Is it odd or even? Any idea? Think about the concept. If you pick the same x value for positive and negative, they have to give you the same y value. Do we have that condition satisfied here? No. So if this is pi over 2, then somewhere in the middle, so this graph is like this. So somewhere middle here, we have pi over 4, right? So for this pi over 4, this is our y value. And we have another pi over 4 here, which is negative. For that, our y value is there. So for same pi over 4, when it's positive or y is positive. When it's negative or y is negative. So what type of function is this? Odd or even? Is it even function? Tangent is not even, because in order to be even, your negative x and positive x, they have to give you the same y value. But tangent doesn't give the same y value for pi over 4. So tangent is odd. Since tangent is odd, which one is odd also? Cotangent. In other words, only two functions are even, cosine and secant. Everything else are odd. You must remember them. So if you did not understand what I did, best thing to do is memorize. And you must remember the condition. In order to be even, the positive x or negative x doesn't matter. They have to give you the same y value. But in order to be odd, if you replace x with negative x, so your y value turns into a negative y value. So let's say if x is 1, if x is 1 and y is 2, this function will be even if x is negative 1, but y is still 2. This is what it means, this condition. Sorry, the other condition, even. Positive x or negative x doesn't matter, your y is always same. But the odd says if x is 1 and y is 2, then for x negative 1, your y has to be negative 2. That is the condition to be odd. If you replace x with negative x, you have to get negative of the original function. Question 3 says, well, some functions are given. Figure out what are these. Odd or even. I'll do only one of them. Which one you want me to do? A, B, or C? Which one looks harder? My morning call said the same thing. C. Okay, so we know secant is what? Odd or even? Secant, even. And cosine? Odd or even? Even. How about cosecant? Odd or even? Odd, right? So in order to check this, we replace all the x with negative x. So we write cosecant, we write cosecant negative x whole thing square. Oh, by the way, when a trig function has a power, for example, trig square x, this is same as trig of the function, trig of the angle with the square power. Let's say n. It's a general rule. What does that mean? It means if you have sine square x, this is same as sine x whole thing square. If you have, let's say, cosine cube x, this is same as cosine x whole thing cube. So when the trig function has a power, it belongs to everything. But if the angle has a power x, then it doesn't belong to everything. That means we can rewrite all of these as this one, cosecant x whole thing square, because this one belongs to everything. Same thing, this one, it belongs to everything. So we can write negative cosine x whole thing with a cube power. We can move around the power as we feel comfortable. For me, when I see the power outside, I can see what is happening inside. But some people, they don't need to do that. They simply see everything and they understand everything. I'm a slow learner. So I actually see things. I'm a visual learner. So when I see things, I can understand better. So I always move my power around so that I can see what is our base. So cosine doesn't have, secant doesn't have any power. We leave the secant alone. You don't have to write this step if you are comfortable with the original setting. Okay, so first step to figure out whether they're odd or even, we replace all the x with negative x. So instead of f of x, we write f of negative x. Instead of cosecant x, we write cosecant negative x whole thing squared. Same thing, instead of secant x, what do we write? Secant of negative x. And cosine of x, we write cosine of negative x whole thing cubed. So I did nothing. I replaced all the x with negative x. And I just moved my power so that I can see what is happening in the base. Now, cosine is an odd function. So odd function says if you replace x with negative x, the whole thing becomes negative. It means we get negative of the cosecant x. This is what being odd means. This thing becomes negative of the original function. But we still have our square power outside. Now, secant is an even function. So for even function, if you replace x with negative x, what happens? Remember, f of negative x becomes f of x. So secant of negative x will become what? Secant of positive x. The x doesn't change anything because secant is even. Even function doesn't care about the sign. It always the original one. Now for cosine, we have our cube outside, but so secant of negative x is secant of positive x. And how about cosine of negative x? What do you get from cosine of negative x? Cosine of x. Because this is even. Even function doesn't care about the sign. It's always the same thing. How? Memorize it. There are two functions. There are only two functions that are even, cosine and secant. Except that, everything else are odd. And since they are even, that means cosine of negative x is cosine of positive x. This is what being even means. Secant of negative x means it's secant of positive x. The negative doesn't affect the angle or the function. And being odd, it means if you have sine of a negative angle, it's same as negative sine of the positive angle. And it's true for the other three. If you replace x with negative, it becomes negative or the positive angle. So we used that concept that cosecant is odd, so negative comes in the front and angle stays positive. Secant is even, so nothing changed. Cosine is even, nothing changed. We get the same original thing back. Now the question is, if you square a negative, what happens to the negative? It becomes positive. So from here, we get cosecant x squared back. Because the negative turns into positive. And we have our secants same. And we have our cosine same. Now we do the thing as before. Instead of writing the power on everything, we can simply put the power on trig function. So this is cosecant square x. Secant doesn't have any power. And the next one is cosine cube of x. Observe this with the original one, f of x. Are they the same or are they different? What you got after replacing x with negative x? Do you get the same f of x back? So we replaced x with negative x, but at the end we found that we got the same original thing back. So what type of function is this? Odd, even, or neither? Even. Question? I didn't do this one. This is easy. If you think for a second, you can figure out the next question. So for A and B, this is what you're going to do. You're going to replace all the x with negative x. And then if they are odd, it becomes negative of the original function. If they're even, it becomes same thing back. It doesn't change anything. Clear? Do you remember the reciprocal identities? It means sine is 1 over cosecant. So cosecant is 1 over sine. And then you have cosine x, and then you have secant x. Then you have tangent x, then you have cotangent x. So these are reciprocal identities. The quotient are two of them, sine and cosine, sorry, tangent and cotangent in terms of sine and cosine. So tangent x in terms of sine and cosine is sine x over cosine x. Can you guess what will be the cotangent? What over what? Tangent is sine over cosine. So what is cotangent? It's reciprocal. Cosine over sine. So you're going to fill out the rest for cosine is 1 over secant. Secant is 1 over cosine. Tangent is 1 over cotangent. Cotangent is 1 over tangent. Actually, let me just write them down. This is 1 over secant. So secant must be 1 over cosine. Tangent is 1 over cotangent. So cotangent has to be 1 over tangent. You have to memorize all of these identities. So from today's recitation, you have to memorize two things. Odd function, even function. Which one of those are odd? Which one of these are even? And all the identities. These two are base of all three. The all three are everything. Any question? Okay, in the next page. So these are actually most important. We use them a lot to prove identities. So they are very useful to prove identities. And you're going to prove many identities in this class. In your exam, there will be one proving identity. Can I change my page? No? Okay, no problem. In the next page, we have simplifying expression using sine and cosine. So whatever is given, we convert everything into sine and cosine. Question 6. Question 7 and 8 says prove this. No, 7 says simplify and 8 says prove, but we're going to do the same thing. We're going to use the identity sine squared plus cosine squared equals 1. Using that identity, you're going to simplify question 7 and 8. So now looking at question 6, which one you think is harder? A, B, C, D. We are going to simplify the expression. That's it. Using sine and cosine. Fine. So which one you want me to do? A, B, C, or D? Any suggestion? No suggestion? Come on, guys. I want to help you. So which one do you think is harder for you? B. B? B is actually nothing. It's only one step. It's 1 over cosine square, and that's it. You're done. See? Okay. So see what is cosecant in terms. What is cosecant in terms of sine? Cosecant is what over what? 1 over sine. So this is 1 over sine x. And how about tangent in terms of sine and cosine? What is tangent? Sine over cosine. So we have sine x on the top, sine x on the bottom. They cancel out. We're left with 1 over cosine. And what is 1 over cosine? Secant. So either one of them is correct. Either left it as 1 over cosine, or you write simplify more secant. D, once you replace, you're going to do keep, change, flip, and then do the same thing what I did in C. Cancel and rewrite. But first step, you're going to rewrite cotangent in terms of sine and cosine, and you're going to rewrite cosecant in terms of sine. And then cancel them. And B is the easiest one. You have just 1 over cosine, and that's it. 1 over cosine square x. And you have nothing else to do. We'll stop. Now between 7 and 8, which one you think you need my help? 8? Okay, no problem. I guess done with my screen. So 8 says, prove this, that 1 over tangent squared gives us secant square. First step, rewrite the left side in terms of sine and cosine. It means we write what is tangent, whatever what. So this is sine square over cosine square. Step 1. Step 2 says add the two terms. So we have 1 plus sine square over cosine square. In order to add them, what do we need? What do we must have in order to combine them? Common denominator. What is our common denominator? What is the LCD? Cosine square. We have only one denominator. So we want to have cosine square here. We need it, so we write cosine square below 1. But in math, everything is fair. If you put something on the denominator, what do you have to do? Put the same thing on the numerator. And now you're happy because they both have same denominator. So we write the denominator only once, and we go ahead and combine. We combine the numerators. So we have cosine square x plus sine square x. That was step 2. Combine fraction and non-fraction together. We did it. Next step says when you combine them, use the fact that if you have sine square and cosine square, if you add them, it becomes 1. So sine square plus cosine square is 1. That means on the top, we had cosine square x plus sine square x. On the bottom, we had cosine square x. Now, how much is cosine square x plus sine square x? 1. In addition, the order doesn't matter. Sine square plus cosine square is same as cosine square plus sine square. So this thing is 1. Because they told us this is 1. And we have cosine square x as our denominator. So this is part C. Replace the numerator with 1. And lastly, part D says, what do you observe now? 1 over cosine square. What is 1 over cosine square? Secant square. So this comes here. This thing is secant square x. So what we just did is this. We started with the left side 1 plus tangent square. After simplifying, combining, taking LCD and everything, we realize that the right side becomes secant square x. So we proved our identity. The left side turns into right side. And that's how we prove identities. We start with one side. At the left side or right side, it doesn't matter. Usually we start with left side. And then we do something. We modify things. Once we modify, we simplify, and then we get back to the right side. If you don't have the right side, something is wrong. Or maybe the identity is false. It is a false identity. But here is a right identity. If you add 1 with tangent square, it does give us secant square. What does that mean? It means if you shift your tangent graph 1 unit to the right, it becomes the secant graph. not secant, sorry, secant square. If you shift it tangent square graph, 1 unit right, it becomes secant square graph. They are the same thing. And this one says if you add sine square graph with the cosine square graph, it becomes the horizontal line 1. Really? Sounds weird. So this is one identity, this is another identity, which you're going to use a lot in trigonometry. And there is one more identity, 1 plus cotangent square is cosecant square, yeah. So another identity we use is 1 plus cotangent square gives us cosecant square. These are 3 identities we often use. Mostly we use this one. We use this a lot in trigonometry. And then this is the second one we use most. And this one we use rarely. Not that much. Okay. So with this, we are done with recitation. Don't leave. Do your recitation. I'm going to collect the old ones. So whatever you have from before, if you have them, after forward, I'm going to collect them. Unfortunately, I don't have your one today. I have it in my home. So I'm going to bring it in my next class. I'm going to pause the sharing.